Kaposi sarcoma is a type of cancer that's not very common in the US, but it's the most common kind of cancer among men in Mozambique, and it's typically associated with AIDS infection.
In this project, we come up with a simple solution to improve patient care in resource-limited setting.
Our current forecasted cost is about 75 cents a diagnosis. This compares to $3,000 a diagnosis that you would get with a more conventional MRI or 3D ultrasound.
We'll take a single snapshot image of maybe a lesion on someone's toe, and from that single snapshot image, we can convert into a 3D model that can be used in the United States with a clinician to possibly diagnose whether this cancer is becoming malignant or not.
We took a commercially available digital camera, which you can buy on the market for about $200, and we used an innovative software program to actually extract information on depth. We turn what would ordinarily be a two-dimensional flat snapshot into a full three-dimensional rendering. In one sense, it's cutting edge, but it's something that every photographer has probably been doing for the last 200 years. And that's when you take a photograph, there's some parts of the image that are in focus, and there's some parts of the image that are out of focus. And your brain can tell whether parts of that image are in the far field or whether parts of that image are closer to you based on whether it comes into focus or is not coming into focus.
We managed to make it really user-friendly to produce 3D clinical photography. It is not only display the appearance of a lesion, but also the height of the surface. And this could not be achieved with a simple setup before.
The setup provides standardized imaging conditions in terms of the camera orientation and the illumination, so that the 3D processed images from different stages of the treatment can be compared and further analyzed by a specialist in another country.
We have collaborators at the largest public hospital in Mozambique, and they take digital snapshots of Kaposi sarcoma tumors with this adapted Lytro camera that's battery powered, that does not need electricity, and those images can be uploaded with a moderate strength cell phone connection to be remotely analyzed, and the important information can be summarized and then sent back to that person in the field so that they can make a diagnosis. Being able to get volume information of a growth in a single snapshot and doing it at such a cheap cost of about 75 cents a diagnosis should be broadly applicable, and we are working hard to try to find other applications that would be useful to apply this technology toward.